Hey, Marley, what you doing?
I'm searching for evidence of water on Mars.
I mean, it looks like you're playing the Mars rover game here at the Space Center.
I am, and it teaches you how to search for evidence of water on Mars.
That's pretty awesome. Oh, look at you go! Wow, it's really cold, minus 38 degrees.
Mars is pretty cold, even though it's as red as it is.
We're gonna learn about that and more on this episode of Space Jams.
This month at the Space Center, our theme is the science of science fiction.
And as both scientists and sci-fi nerds, there are a million things that we could talk about.
Definitely, but we decided to focus on one thing, or rather one planet in particular, Mars.
Mars has been both a destination and a location for many different sci-fi books and movies. But what would an actual Mars mission look like? And what kind of challenges would the humans going to Mars actually face?
Find out on this episode of Space Jams.
First of all, we have to get to our neighbor, the red planet. The journey to Mars with our current spaceflight technology takes about 6 to 9 months. Mars missions we have launched in the past have taken about 7 months to get there, but those have only had robots such as Curiosity and Perseverance on board. Humans require a lot more stuff to survive, like water, food, oxygen, shelter, and a way to bring all of those things to the Martian surface with us so we can set it up once we get there.
At this point, we have a pretty good idea of how humans survive 6 months in microgravity. That's because that's the average mission length for astronauts on the International Space Station. Life on the way to Mars will be pretty similar to the life on the International Space Station, but probably a bit more cramped. They'll have to worry about similar things on the way there, just like making sure that they exercise enough to prevent their muscles from atrophying from lack of use. Readjusting to a planet with gravity is hard enough after months in microgravity, let alone when you have to set up shelter and other ways to survive. The gravity on Mars is only 38% of that here on Earth, but it'll still be a huge shock to the system. More importantly though, the Martian atmosphere is only about 1% of that on Earth, and it's mostly carbon dioxide. So you have to figure out a shelter, and you have to figure out a way to breathe, and also air pressure. The Earth's atmospheric pressure at sea level is about 14 psi. On Mars, it's 0.095 psi. It's also freezing cold. The temperatures on Mars range from a mild 20 degrees Celsius to a bone-chilling minus 153 degrees Celsius. So, astronauts on Mars will need shelter, pressurized rovers for transportation, and spacesuits to breathe and stay warm. Another thing that shelter on Mars will have to take into consideration is space radiation.
The astronauts on the ISS are already exposed to a lot of space radiation, the equivalent to about 150 to 6,000 chest x-rays, depending on the length of their mission. We are protected down here on Earth from this ionizing radiation, x-rays and gamma rays coming from very high energy events out in space, because of our magnetosphere, a magnetic field wrapped around our planet like a safety blanket. But the ISS orbits above our magnetosphere.
The Mars Odyssey spacecraft studied the radiation on Mars and found that it is 2.5 times that on the ISS. There are also a lot of solar storms on Mars, which could peak radiation even higher. Unlike Earth, Mars does not have a magnetosphere, though it likely did have one a long time ago. Areas of the Martian crust in the southern hemisphere are highly magnetized, indicating traces of a magnetic field from 4 billion years ago.
Billions of years ago, Mars could have been much better suited to life than it is today. It likely had a much thicker atmosphere along with a magnetosphere, which held in heat to the planet's surface. There's evidence in the rocks of Mars that large amounts of liquid water once flowed on its surface. But now that water is all frozen up in polar ice caps. One of the scientific reasons to go to Mars is to continue to look for evidence of ancient life that may have existed on Mars when it was more habitable. And on a crewed Mars mission, there will be a lot of time for science.
The astronauts will have to wait about a year to a year and a half for Earth and Mars to line back in their orbits for them to be able to come home. Both the Earth and Mars are orbiting around the Sun, but at different rates. So both launching to Mars and returning to Mars has to be carefully timed so the journey is the shortest possible. When closest, the distance between the two planets is about 54.6 million kilometers. At their furthest, it's over 400 million kilometers.
Which is why it took so long to rescue Mark Watney in The Martian, because if they had just turned around, Mars would be getting farther and farther away.
There are many different proposals as to how we could shelter astronauts from the dangers of Mars for the time they have to live on the surface. Some have proposed building habitats underground in the Martian soil to use the planet itself as a shield. Another uses robots to 3D print a ceramic shell on a shelter using Martian soil, similar to what NASA and the European Space Agency have proposed for a moon shelter as well. You're probably wondering, how long is it going to be before we send humans to Mars?
NASA's current predictions are the late 2030s to the early 2040s. Some private companies, such as SpaceX, have loftier goals of going even earlier in 2029. But this depends on advancements in technology and how spacecraft and shelter testing goes over the next few years.
A lot of testing is going to be happening when we go back to the moon.
Next month, we're going to start a series called Back to the Moon, which is going to be looking at how going back to the moon with the Artemis missions is going to help us prepare to one day get to Mars.
See you next time!